Hi everyone. Thanks for being here today. My name is Mohamed. I'm going to talk about stretching the limits of S3 backend for OpenTofu. So it's a bit of a mouthful title, so let's dive in. So before I get started, raise of hands, how many of you guys have heard about the term like tacos or Terraform automation collaboration software? Okay, so like half of you. So let's dive into a story. So one of the greatest parts about OpenTofu, is that when you get started, it's just a CLI that you can just download. You write some HCL code, and then you can start provisioning resources immediately. When you outgrow that and you want to collaborate, you push your state file to S3. So you have a bucket, and then you have your team now collaborating with OpenTofu. At some point, you outgrow that. As we saw in the previous talks, we see like you need a module registry. You need more than just Terraform and a bucket. So that suite of tools is called Terraform collaboration software, or tacos. We're currently building a self-hostable taco called OpenTofu. So it's fully open source and it's self-hostable. And when we got started with it, we started to ask ourselves, like, what if all you needed was that bucket that you set up initially? So you don't need like managed databases, queues, lots of complexity, at least to get started. And so like we started to experiment with that. And I'm here to share with you like some of our findings along the way over the past few months. So in the beginning, the first setup we had was, okay, so this tacos is like a bunch of services that you host in your cluster, and they sit in front of your bucket, and they give you more capabilities to your OpenTofu setups. So in the beginning, our first setup was, okay, let's just use the same S3, but let's write some additional metadata as JSON files, which is essentially using the bucket as a database. But we quickly ran into a lot of bottlenecks because when you join different tables and so on, you definitely hit a lot of performance. So as an example, I don't know if that's visible, but for 28 records, it was taking 8 seconds with units and the RBAC metadata for it. So that doesn't work. Our second attempt was kind of inspired by OLAP, so analytical databases. So we started to say, okay, let's keep the writes and the edits as JSON records, and then let's set up like a cluster, a Trino cluster for the reads. Well, that did work, but it felt a bit too complicated as a setup, and it needed a lot of like AWS native services, so it's not like transferable. So then we thought, okay, we need like a transactional database set up around S3. What's the most popular one? We went back to the whiteboard and we thought, okay, SQLite is pretty good. It's in memory. We can use SQLite mounted inside the service, and we can have a write-ahead log. So with the light stream, it can write back to the bucket while it's in memory, and as it loads up, it can load all its metadata. So the limitations here is that you can't have like a replica of the service because it's like doesn't work, but it worked really well, and yeah, it worked really well. And the benchmarks for that was compared to like the 8 seconds of our initial thing, we went it down to like less than a second. I had a video somewhere, but we couldn't get it in the talk. But you can meet me outside. I'll show you. So yeah, would love for you guys to try OpenTofu. You can log in with the OpenTofu CLI with Tofu login. Yeah, that's the end of my talk. I would happily take questions now.
hopefully an easy one. What kind of license does it have?
MIT. We are MIT licensed. So the question was, what's the
Very
license of OpenTofu, OpenTofu project?
Well, if you don't mind me asking, why did you choose the MIT license?
It's the good balance between like permissible and allows us as a commercial company to like monetize later as well.
Cool. Thank you.